Welcome back to Talk Tensors. We love breaking down the latest and greatest in machine learning research.
Absolutely.
And today we're diving into something really special.
Oh, yeah.
It's called Neural Radiance Fields for the Real World. A survey.
Catchy title.
It is a catchy title, and this paper maps out the evolution and the really exciting possibilities of this groundbreaking technology.
Groundbreaking is right. I mean, you've probably seen some of the amazing 3D images and videos that NeRFs can create, right?
Oh yeah, it's like magic.
It is like magic.
But for those of us who aren't, computer graphics wizards,
Right.
it can be a little hard to wrap our heads around how it actually all works.
Well, that's where this survey paper comes in.
Okay, tell me more.
It really breaks down the key advancements in NeRFs, explores their applications, highlights the challenges researchers are tackling.
So it's like a roadmap
It is.
of how NeRFs are changing the way we interact with the 3D world.
Exactly.
And we're here to guide you through it.
Absolutely. Let's do it.
So this survey paper, it does a really good job of consolidating the massive amount of research that's happening in the NeRF world right now.
It really does. I mean, it's incredibly comprehensive. It lays out all the core concepts, highlights key advancements, explores challenges, applications.
It's a great guide.
Yeah, it really is a great guide.
I think for our listeners who may not be, super familiar with this,
Right.
let's start with the basics.
Okay. Sounds good.
What exactly are neural radiance fields?
Okay, so imagine you want to teach a computer to see in 3D, just like we do.
Okay.
You could show it tons and tons of 2D pictures of an object or scene taken from different angles.
Got it.
And a NeRF uses a neural network to learn how those 2D images relate to each other in 3D space.
So it's like the computer is building a mental model of the scene.
Exactly.
But instead of using traditional methods like voxels or meshes,
Right.
it's using a continuous function.
Yeah, so instead of creating like a bunch of little blocks or polygons to represent the scene,
Right.
it's using math to describe the way light interacts with every point in space.
And that's why NeRFs can capture such fine detail
Yeah.
and complex lighting effects.
Precisely. It's like the computer is actually simulating how light rays would travel through the scene,
Wow.
creating a truly immersive experience.
That's pretty amazing.
It is pretty amazing.
This technology didn't just appear out of thin air, though, right?
Oh, of course not. Yeah.
What were some of the key milestones that led to the development of NeRFs?
Well, the paper does a great job of kind of tracing the lineage,
Okay.
starting with the original paper that was published back in 2020.
Mm-hmm.
That initial work was groundbreaking.
Yeah,
But, like a lot of early work, it had its limitations.
of course, yeah.
For example, rendering images took a really long time,
Uh-huh.
and it required a massive amount of input images.
So like any new technology, there were some kinks to work out.
Exactly.
What were some of the key innovations that addressed those early limitations?
Well, one major breakthrough was the development of what we call hierarchical volume sampling.
Okay, break that down for me.
It's a much more efficient way to render images.
Okay.
Instead of just like blindly sampling every point in space, right?
Wow.
It strategically focuses on the areas where the most visual information is concentrated.
So it's kind of like a detective,
Yes.
zeroing in on the most important clues
Exactly.
instead of combing through every inch of a crime scene.
Exactly. That's a great analogy.
That makes sense.
Yeah,
Were there other innovations that helped to speed things up?
absolutely. So there's this thing called MIP-NeRF,
Okay.
and it addressed the issue of aliasing.
Now remind me what aliasing is again.
It's those jagged edges
Oh, right.
you sometimes see in computer-generated images.
Right.
So MIP-NeRF, it's based on this classic computer graphics technique called MIP mapping.
Okay.
And what MIP mapping does is it uses multiple resolutions of a texture to create a smoother, more realistic look. So MIP-NeRF basically applied this concept to 3D scenes, which drastically improved the visual quality.
So hierarchical volume sampling made things faster.
Yes.
MIP-NeRF made things look better.
Yes,
But were there any other improvements beyond just speed and visuals?
definitely.
Okay, what else?
So researchers also developed what we call feature encoding techniques.
Okay.
And these are all about organizing the massive amount of 3D scene information that NeRFs need to process.
Oh, I see.
Right. It's like coming up with a super efficient filing system for a library with millions of books.
That's a good analogy.
Yeah. And this made NeRFs even faster and more capable of handling increasingly complex scenes.
Okay, so to recap, we've gone from this relatively slow and clunky first version of NeRFs to a technology that is faster, more efficient, and capable of creating incredibly realistic 3D representations.
We have.
It's pretty remarkable progress in just a few years.
It really is.
I'm guessing it wasn't all smooth sailing, though, right?
Of course not. There were definitely bumps in the road.
What were some of the challenges
Oh, there were many.
that researchers faced as they tried to bring NeRFs out of the lab and into the real world?
Yes, the real world, the wild west of NeRF research.
Yeah,
Yeah, the real world is a much messier place than a controlled lab environment.
that's true.
Researchers quickly realized that NeRFs, as impressive as they were really sensitive to certain real-world imperfections.
That makes sense.
Yeah,
I mean, in the lab, you can use these high-quality cameras,
exactly.
carefully controlled lighting,
Yep.
perfectly positioned objects.
Uh-huh.
Things are rarely that pristine out in the wild.
Never.
What were some of the specific challenges that cropped up when you took this out into the real world?
Well, one of the biggest hurdles
Yeah.
was dealing with what we call degraded views.
Degraded views, okay.
So NeRFs typically rely on these really high-quality images as input.
Yeah.
But in the real world, images can be blurry, noisy, or low resolution.
Sure. Like if you're taking a picture with a shaky hand,
Exactly.
or like in low light, or maybe even with a phone camera that's seen better days.
All of those things, yeah. So it's like trying to bake a cake with stale flour and wilted eggs.
You might end up with something, but it's not going to be pretty.
Exactly. Exactly. So researchers had to come up with ways to make NeRFs more robust,
Okay.
more resistant to these imperfections.
So essentially like making them less picky eaters.
That's a great way to put it. And they actually came up with some really clever techniques.
Like what?
Well, for example, to deal with blurry images caused by things like motion blur or out-of-focus shots.
Yeah, those are common problems.
Very common. So what they do is they use this clever trick
Okay.
where they simulate the physical process of how that blur happens in a camera. And then they essentially rewind the blur to get a sharper image.
Oh, wow. So it's almost like having a time machine for photos.
Exactly. Isn't that cool? It's like they're giving NeRFs the ability to see through the blur.
Very cool.
So that's one way they're tackling these real-world image problems.
That's amazing. What about low-resolution images? Can NeRFs do anything to enhance those?
Absolutely. Researchers have actually developed some really cool techniques
Okay.
to improve the quality of low-resolution images before they're even fed to the NeRF.
Oh, wow. So like pre-processing the images.
Exactly. It's like giving the NeRF a head start.
That's clever.
Yeah. And there are different ways to do this.
Okay.
Some methods use super resolution algorithms to upscale the images.
Essentially adding more detail.
Right, like blowing up a small picture without making it all pixelated.
Okay, and how do they do that?
Well, there are a lot of clever algorithms out there, but basically they use machine learning to learn how to fill in the missing details in a way that looks natural.
It's like the algorithm is an artist,
In a way, yes.
trying to recreate the missing parts of the picture.
Exactly. And some methods even go a step further.
How so?
They actually incorporate super resolution directly into the NeRF training process.
Oh, wow. That's interesting.
Yeah, so they're cleverly combining information from multiple low-resolution images to reconstruct a higher resolution 3D scene.
So it's like they're pooling the information from all the bad photos to create one good one.
You got it.
That's amazing.
Uh-huh.
Okay, so we've talked about blurry images.
Uh-huh.
We've talked about low-resolution images.
Yes.
What other real-world, gremlins did researchers have to wrangle?
Oh, there were plenty more.
Like what?
Well, another major challenge was accurately determining what we call camera poses.
Camera poses. Okay.
Remember, NeRFs need to know exactly where the camera was located and oriented when each image was taken.
Right. To understand the perspective.
Exactly. But in real-world scenarios, getting those camera poses precisely right can be incredibly tricky.
I can imagine.
Yeah, it's not like everyone's walking around with these high-precision GPS trackers attached to their cameras.
Yeah, if you're just like snapping casual photos, you're probably not meticulously recording the camera's position and angle for each shot.
Exactly. And even small errors in those camera poses can really throw off the entire 3D reconstruction.
It's like trying to assemble a jigsaw puzzle where the pieces don't quite fit
Yes, that's a perfect analogy.
because someone slightly warped the picture on the box.
Right. So to overcome this, researchers developed all these really smart methods
Okay.
to estimate and correct camera poses during the NeRF training process.
So they're kind of like teaching the NeRF to figure out where the camera was.
Exactly. It's like giving the NeRF a little bit of detective work to do.
Very cool. That makes a lot of sense.
Yeah, and these techniques make NeRFs much more resilient
Okay.
to real-world inaccuracies in camera positioning.
So we've got ways to deal with less than perfect images,
Yes,
and techniques to correct for, wonky camera poses.
we do.
What else can trip up nerves out in the wild?
Well, the complexity of real-world lighting is another big one.
Yeah, light in the real world isn't just a single point source like a light bulb.
It's so much more than that.
It bounces off surfaces, creates shadows, interacts with different materials.
It's a whole physics party out there.
Exactly. And getting all those subtle nuances right
Yeah.
is really crucial for creating truly realistic renderings.
Absolutely.
NeRFs need to understand
Oh, yeah. They need to understand a lot.
how different materials reflect light,
Yep.
how shadows form and interact with objects,
Yep.
and even how light scatters in different environments.
It's a lot to keep track of.
Yeah, it's like the difference between drawing a simple cartoon sun and painting a photorealistic sunset with all those subtle color gradients and atmospheric effects.
That's a great way to put it. So to capture that level of realism, researchers are constantly developing more sophisticated lighting models for NeRFs.
Oh, really? So how do they do that?
They're borrowing concepts from physics and computer graphics to create these more convincing renderings.
Okay, so far we were talking about scenes that are relatively static,
Right.
like a still life.
Yeah.
But the real world is full of movement and change.
Eh.
Can NeRFs handle scenes where objects are in motion or environments that transform over time?
That's a great question. And it leads us to what we call dynamic NeRFs.
Dynamic NeRFs, okay.
These are designed to capture movement and change over time.
That opens up some pretty incredible possibilities. I mean, imagine creating a NeRF of a bustling city street with cars driving by, people walking around, birds flying overhead.
Absolutely. Or a NeRF of a forest with leaves rustling in the wind and animals darting through the undergrowth.
That's amazing. How do they make these dynamic NeRFs work?
Well, there are a few different approaches.
Okay.
Some methods treat the scene as a 4D space,
Okay.
with time being that fourth dimension,
Got it.
which allows them to capture the changes that happen over time.
Makes sense.
Others separate the scene into static and dynamic components,
Okay.
and they model each one individually.
So it's like separating the background from the foreground.
Exactly, like a green screen for the real world.
Yeah.
And there are even techniques that learn a deformation field.
A deformation field. What's that?
It's basically a way of tracking how the scene changes over time,
Oh, I see.
like watching a piece of clay being molded.
Oh, that's cool. It seems like researchers are constantly finding new ways to push the limits of what NeRFs can do.
They really are.
But let's talk about another type of complexity.
Okay, shoot.
What about those vast, unbounded environments?
Ah, yes, the great outdoors.
How would you create a NeRF of, say, a sprawling mountain range or a seemingly endless desert?
That brings us to what we call complex scene configurations.
Complex scene configurations. Got it.
Real-world scenes aren't always neatly contained.
Right. They can be sprawling and messy
Exactly.
and full of, weird angles and shapes.
Exactly. Think about indoor scenes with intricate geometry and lighting.
Oh,
Or those unbounded scenes that stretch out as far as the eye can see.
it's like the difference between building a Lego model on your table and trying to recreate the entire Grand Canyon out of Lego bricks.
I love that analogy. It's perfect. So for those indoor scenes, researchers are exploring ways to incorporate additional information.
Like what kind of information?
Things like depth maps or semantic labels
Like,
to help the NeRFs understand the complex geometry and lighting.
so it's like giving them a little extra help to see the world.
Exactly. And for those unbounded scenes, they've developed some techniques to represent the scene more efficiently.
Like what?
Well, one way is to break the scene down into smaller, more manageable chunks.
Divide and conquer.
Exactly. Or they might use special mapping functions to handle the vast scale.
So they're like cartographers of the 3D world, figuring out how to map and represent these vast, complex landscapes.
I like that, yeah. It's
Yeah.
like creating a 3D map of reality.
It's amazing how they keep finding solutions to these real-world challenges.
It is pretty
I
remarkable.
have one last question about this whole real-world complexity thing.
Okay, what is it?
What about situations where there's like uncertainty?
Uncertainty, right?
What if something is blocking part of the scene
Uh-huh.
or the lighting changes suddenly?
The question of uncertainty. That's a really important one.
It is. It's like trying to solve a mystery where some of the clues are missing or unreliable.
That's a good way to think about it. And it's an area where researchers are really starting to, come up with some creative approaches.
So how do NeRFs deal with that uncertainty?
Well, one approach is to kind of bake that uncertainty directly into the NeRF model itself.
So instead of just predicting what the scene looks like,
Right.
it also estimates how confident it is in that prediction.
Exactly. It's like the NeRF has a built-in BS detector.
So they can tell us Not only what they see, but how much they trust their own perception.
Exactly. Pretty cool, right?
Yeah. Are there other ways to deal with uncertainty in NeRFs?
There are, some researchers are using multiple NeRF models,
Okay.
each trained on slightly different data
Okay.
or with slightly different assumptions.
Let's see.
And this creates a sort of ensemble of NeRFs,
An ensemble.
where each model offers its own perspective on the scene.
Right.
And by combining all of those perspectives, you can get a much more robust,
reliable reconstruction,
makes sense.
even in the presence of uncertainty.
So it's like getting a second opinion.
Exactly. More like 100 opinions.
100 opinions.
Or 1,000, or however many models you want to use.
Right.
Okay.
So we've covered a lot of ground on the challenges of bringing these NeRFs into the real world.
We have.
It seems like researchers are making incredible progress in overcoming those hurdles.
They really are. It's an exciting time to be in this field.
It is, but let's shift gears now
Well,
and talk about what we can actually do with this amazing technology.
yes. Let's talk applications.
Besides creating, stunningly realistic 3D models.
Of course, but there's so much more.
What are some of the exciting applications that are emerging?
Well, one area that's really generating a lot of buzz is 3D surface reconstruction.
Okay.
Imagine being able to create a detailed 3D model of an object or an environment just from a handful of photos.
That would be amazing.
It has huge potential for fields like archaeology, architecture, even interior design. So no more painstaking measurements and meticulous modeling.
Yep.
You just snap a few pics
That's the idea.
and boom, you have a perfect 3D replica.
Exactly. That's the dream.
Now, what about larger scale environments?
Oh, yeah.
Can NeRFs handle those?
Absolutely. Researchers are using NeRFs to build 3D models of entire cities,
Wow,
underwater environments,
Oh.
even scenes from satellite images.
that's incredible.
This could revolutionize urban planning, environmental monitoring, even space exploration.
It's like giving us the power to rebuild anything we can capture with a camera,
That's a great way to put it.
from like a tiny seashell to an entire city.
Yeah. The possibilities are pretty mind-blowing.
They really are. And the paper also mentioned some applications in like medical imaging and robotics.
Right. Those are two really hot areas right now.
How are NeRFs being used in those domains?
Well, in medical imaging, NeRFs are being used to create 3D reconstructions from medical scans, which gives doctors this much richer and more interactive way to visualize a patient's anatomy.
So it's like having X-ray vision on steroids.
Exactly. And this could be really valuable for things like diagnosis, surgical planning,
Wow.
even personalized medicine.
And what about robotics? How did NeRFs fit into that world?
Well, robots, they need to see the world to navigate
Of course.
and interact with it effectively.
Right.
And NeRFs can provide them with a much more detailed and nuanced understanding of their surroundings.
Instead of just seeing a collection of objects,
Right.
they can understand the shape, the texture, the lighting of the environment.
Exactly. And this could lead to robots that are much better at navigating complex spaces,
Right.
manipulating objects, interacting with humans in a safe and intuitive way.
So we've got NeRFs for doctors,
Uh-huh.
NeRFs for robots.
NeRFs for everything.
It seems like the possibilities are kind of endless.
They really are. It's a very exciting time.
But I think it's also important to talk about the potential downsides. The ethical
Oh,
consideration.
absolutely. With any powerful technology, there are
Yeah.
always potential risks.
And the paper did touch on this briefly, the risk of, deep fakes.
Right.
Could someone use NeRFs to create fake content that's indistinguishable from the real thing?
That's definitely a valid concern.
It is.
As these NeRFs become more sophisticated
Right.
and easier to use, the potential for misuse is, unfortunately going to increase.
Right.
So it's crucial that we start thinking about these ethical implications now.
Absolutely. We need to be having these conversations.
We do.
And consider the potential consequences
Yes.
as this technology evolves,
Early and often.
early and often. But let's end on a positive note here.
Okay, I like it.
What's next for NeRFs?
The future is bright.
What are some of those novel notions that are on the horizon?
Well, one really exciting area is the development of even faster and more efficient NeRFs.
Okay, so even faster than what we have now.
Yes. Imagine being able to render complex 3D scenes in real time, even on a mobile phone.
That would be incredible.
It would. This could open up all sorts of amazing opportunities for immersive gaming, interactive art, virtual tourism.
It's like having a holodeck in your pocket.
Exactly. The holodeck is coming.
What else is brewing in the NeRF world?
Well, there's a lot of interest in using NeRFs for augmented and virtual reality
Oh,
applications.
of course.
Imagine putting on a headset and stepping into a virtual world that's indistinguishable from reality,
Right, yeah.
or overlaying digital information onto your real-world view
Right.
with incredible precision and realism.
Okay, I'm officially geeking out now.
I know, it's pretty amazing stuff, right? Nerf flips could be the key to creating these truly immersive and seamless AR/VR experiences.
But perhaps the most mind-blowing possibility is the idea of generative NeRFs.
Oh yeah, that's the holy grail.
What if we could use NeRFs not just to recreate existing scenes, but to create entirely new ones from scratch?
That's the dream, isn't it? Imagine designing a virtual world or generating a 3D model just by describing it. We're still in the early stages of exploring this,
Sure.
but the potential is just staggering.
It's like having the power to create entire universes at your fingertips.
It really is. So that wraps up our deep dive into neural radiance fields.
It has been an incredible journey,
It has
exploring the evolution, the challenges,
so many
the
challenges.
astonishing possibilities of this really game-changing technology.
Game changing is right. I think this is going to be huge.
We've seen how researchers are pushing the boundaries of what's possible,
They are, they really are.
tackling those real-world complexities.
Making those NeRFs tougher.
Tougher,
Yeah,
more robust,
more robust.
ready for the wild.
And unlocking this whole new world of applications.
It's like opening up a portal to a new dimension.
It is. It's so cool.
It is.
I think one thing's clear. NeRFs are going to revolutionize the way we see and experience the world.
I completely agree.
So keep those imaginations firing.
Keep thinking about the possibilities. We'll be back soon with more fascinating deep dives into the world of machine learning.
We'll see you then.